Hello friends, today we will learn about DC machine, its construction and its classification. So let's get started. So DC machine is a kind of machine that operates with DC supply for the generation of unidirectional torque or current. So DC machine can be divided into two kinds of machine, that is the DC generator and DC motor. So this DC generator and DC motor both can be divided into two types, that is the separately excited generator or separately excited motor, or self-excited and self-excited motor. So in case of separately excited generator or separately excited motor, the field winding is excited from a separate DC source, and in case of self-excited DC generator or self-excited DC motor, the field winding is excited from the power which is obtained in the armature, that is the rotor. And this self-excited DC generator or self-excited DC motor can be further divided into three types, which is DC series generator or DC series motor, DC shunt generator or DC shunt motor, and DC compound generator or DC compound motor. So in case of DC series generator or DC series motor, the field winding is in series with the armature winding, and in case of DC shunt generator or DC shunt motor, the field winding is kept parallel to the armature winding. And the DC compound machine consists of two windings. One is connected in series and the other is connected parallel to the armature winding. This is the construction of a DC machine. The outer part is called the stator or yoke. Actually, the work of stator is to protect the internal parts, and it also provides support to the pole core and pole shoes. It is made up of cast steel or cast iron, and electromagnet is used in place of permanent magnet because in case of permanent magnet, the strength of magnetic field decreases with time, but in case of electromagnet, the magnetic field gets developed when the current passes through the coil actually. So this is also an advantage, that when the current passes through the coil, then the magnetic field gets developed and the flux actually passes through the low reluctance path. So in this way, flux can be controlled by electromagnet, but in case of permanent magnet, the flux control method is not possible. So this is also an advantage. And the poles are a little bit curved, because if the poles are not curved, then it will not be able to provide uniform distribution of magnetic flux, and the curved poles are known as the pole shoes. So there is a small air gap between the pole shoes and the armature winding, that is the rotor. The stator consists the field winding and the rotor consists of the armature winding, and the field winding takes only small current, whereas the armature winding takes most of the current. There are small slots in rotor where the conductor is kept, and the windings are actually made up of copper wire. Armature winding can be divided into two types based on the way how the armature conductors are connected. So the two types are lap winding and wave winding. And in case of lap winding, the number of poles and the number of parallel paths are equal, and in case of wave winding the parallel paths is equal to 2. And the commutator is the cylindrical path which is actually made of copper bars or segments which rotate with the armature. And through this commutator, the alternating current is converted into unidirectional current in case of DC generator. And this DC machine works on the principle of Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction actually states that whenever a moving conductor is placed in a magnetic field, it actually cuts the magnetic field, and then the EMF is induced. In case of generator, the direction of the current can be determined by Fleming's right hand rule, and in case of motor, the direction of the unidirectional torque can be determined by the Fleming's left hand rule. So that's all for today. Thank you for watching, and please subscribe our channel for more videos.